So have you started question number 7?
Yes, sir.
Okay. I didn't get it. Say it again.
Minus 608.6.
Minus 608.6. Don't you think this is too big of an answer? Can you send me your answer? I mean, your solution? Or can you just
Sir,
tell me what you did?
I subtracted H2 minus H1.
Okay. First of all, stop doing that. Secondly, without even drawing a cycle, how can you know that you simply need to subtract these? Right? How would you know that you simply need to subtract these? Where are the number of moles then? Even if you need to subtract, where are the number of moles? I'm pretty sure that the 3 given before AGF or 3 given before AGI is something that you never kept into consideration. There's 3 and there's 3. Let me in fact change the color. There's 3 and there's 3, right? Which actually changes everything. Okay, I want you to try again, but keep the 3's in mind this time. Maybe you end up at the right answer. Let's try.
Yes, sir. Okay. Sir, 82.4.
With a negative or without a negative?
Without.
No, that's not right. Try it again. Your figures are correct, but it should be with. Numbers for products
Okay,
are
yes,
actually
with.
bigger.
Yes, okay. I got it.
Okay. So this time, let's be on the same page. This time you tried the same thing, delta H1 minus 2, whatever you've been doing pretty much, which is you're subtracting the reactants from the products, all right? So this time you took this value and you never multiplied it with anything, right? And then you took this value, right? Since you started off with this and this, so you multiply this one by 3, then there is a subtraction sign. These were the first values. Then for the second ones, you took this value since you went off with reactants after for the subtraction purposes. And for this value, you actually took under consideration this 3 and multiplied with this 3. And then you got your answer, which is negative 82.4. You said 0.4, right?
Yes, sir.
Is that it exactly?
Yes, sir.
Good, good. Then you get all 3 marks. All right, that's great. Okay. Remember, writing the whole thing for delta HR, the whole thing, that means the negative, this starting value, and then 3 into this one, then negative, then this value, and then 3 into this one, and then calculating everything to get minus 82.4 over here. That way you get all 3 marks. These 3's are important. You can't miss them out. Okay. All right, let's move on. Let's see what we have on the next page. Okay, another enthalpy change of reaction. Let's try this one too. And if I see that you're too good with enthalpy change of reactions from formations, which actually is pretty easy, then I'm not gonna go with any more type of this question. We're gonna switch the types. We'll try doing the bond energy questions. We'll try doing the combustion questions, all right? Let's see if you can get this one correct.
Yes. Minus 17.
Yes, minus 17. What are the units?
kg per mole.
Right, it's already given as a part of the answer. It shouldn't be a problem, right? Since it's already written over here, so this shouldn't be a problem. So negative 17. You said something else too. I couldn't get that.
Negative 17.0.
Oh, all right. I was about to talk about this 3 significant figure rule, but yeah, that's great. I hope you considered the same way of solving it. I hope you considered the ratio numbers this time, 2HF and 2HCl, right?
Yes, sir.
Good, great, great. That means that all of it is correct. Okay, let's see what more do we have. And that's a good one. Go ahead. Let's try this one. 9A.
Sir, I don't get the question.
Okay, the bond energies are given to us, and we are going to use this data, and we're going to talk about the conversion of sulfur dioxide into sulfur trioxide to calculate the value of SO bond energy in SO3. Now, let me explain that the structures, you might not be getting this since the structures are very important in this whole thing. So what I'm going to do is that I'm going to write an equation for you. This is the equation that we had back from the contact process. Remember it? We converted sulfur dioxide from further oxidation with the help of further oxidation into sulfur trioxide, right?
Yes, sir.
Now, I hope you understand that this is the structure for sulfur dioxide. This is for oxygen, and this is the structure for sulfur trioxide. All right. Now, if you have these structures, and you know this one would be 2 and this one would be 2 for balancing, if you have these structures, only then you can draw a diagram for this one and then solve it. Now, since you have been using the products minus reactants rule so far, that's why you have a little bit of a problem drawing the diagram. What I would really suggest is to open the book in front of you and keep the page of the book which explains the ammonia question as an example to find out the bond energies. Keep that in front of you so that you can easily draw the enthalpy cycle, I mean the whole energy diagram, and then try to solve it. Will you be able to do it on your own if you take a little bit of a help from the book?
Yes, sir, I try.
That's good. Give it a try first. If you're not able to do it, or if you get stuck somewhere, let me know, I'll help, but do give it a try first. I can wait.
Okay, sir.
So,
Yes, sir.
were you able to solve it?
Sir, I didn't get that part, but I solved the rest of them, like question 10 and 11.
Okay, were you able to get question number 11 right?
Yes, sir, but not question number 9.
Uh-huh. And what about 10? Means you were able to solve
Yes.
10 and 11, and you were also able to check their answers?
Yes, sir.
Okay, so let's get back to 11 then. Let's try solving, let's get back to 9 then, and let's try solving 9. Right? So,
Yes, sir.
now, what do you think would be the energy cycle in this whole diagram? Were you able to draw the energy cycle correctly?
No, sir, I didn't draw any energy cycle.
Okay, let's draw it like this. I'm gonna erase this part. I'm gonna convert it into this, and know that it would be converted into 2s plus, that's a total of 6o gaseous, right? And this would be converted into this. So and we do understand we'd have to pour into SO, right? Plus 1 into OO on this side, and this is all going to be plus, and this is going to be minus, since that's the formation, and this is going to be 6 into SO on this side. This is something we need to find. So do you understand so far, or do I need to explain? I should explain it. First of all, we converted all of
Sir,
the by breaking.
Sir,
All of it.
minus 6 kilocalories.
Since there are 3 S11O in one structure, in one molecule, and there are 2 molecules being produced, so 2 into 3 would be 6. Minus is there since this is bond formation, and bond formation is actually exothermic, so we needed to write minus.
Okay, sir, I get it.
Yeah. So if we solve all of this, all right, so wait a second, this whole thing should be equal to something specific. Just a second. There is something missing from this question. Until unless we have the whole value for this reaction, we won't be able to proceed. I mean, if there is some bond
Yes.
energy absent, then we need the total delta H for this reaction. From what I know from O levels is that we do understand this reaction is exothermic, but I don't exactly know this value in negative over here in kilojoules per mole. And since we don't have that value, we won't be able to solve the whole thing, because what we're going to do is that we do understand that the delta H would be equal to this 4 into SO plus OO minus 6 into SO. And we once we get all of this, delta H minus 4SO minus OO is equal to minus 6O, right?
So
and
in
if
the
we want to
margins,
cut,
I think it's 196.
minus 196,
Delta X. Yes.
okay. So
And
adding
then
these,
the final answer is 471.3.
no, what if you do the calculation from here, or is that seem to be the same? If that seems to be the same, you need to recalculate it.
Yes, sir.
If that seems to be the same, no need to recalculate it. I'm saying if
Okay,
this
sir.
solution seems same as marking scheme, since that's not in front of me, if you think the whole thing is same, the same values have been taken with the same multiplying factors, then I think you already
Yes.
know how we solved it, right?
Yes, sir.
Okay, good, great. If that's the case, then you already know how we got your answer. And you were saying something 400 and what?
471.3.
471.3. Right. Make sense?
Yes, sir. But sir, will they always give us the delta H value?
Okay, let me tell you something about read and write or these topical books. They sometimes take the second and third part of the question. They show it as part A, but if to be honest, it was actually the part B of the question. So the negative 196 value must be present as the part A of the question. And since they only take the part out which is related to this topic, they sometimes miss very important values. That's why sometimes you're not able to solve the questions until unless you see the whole thing, or until unless you get the prerequisite for a question. For example, for a question like this, there must be a prerequisite given in part A where the delta H value was given as minus 196, this one, right?
Yes, sir. Okay, sir.
So that would be given as a part of the paper. They never ask you to play blind. Remember, Cambridge papers are very technical, but they don't need you to cram those kind of values. Not every person can cram all the reactions in the word and what their enthalpies are supposed to be. All right?
Yes, sir.
Good, good. So let's erase it all. Move on. Okay, let me check number 10. It's about formation. So this seems easy. 11 is something that we did as a part of the example. We never tried to find out the initial bond energy value, but this equation in this whole thing is a part of the book, so this shouldn't be difficult. How about this one? How about 12? Okay, let me see. 12
Okay,
is
sir.
all about, no, don't get started yet. Just yet. It's again formation. You're simply going to put along with the numbers the products minus the reactants, and you'll get the answer. So let's not try solving this one. I don't want to go with these examples since you're already good at this one. Okay, let's see what we can do. So in this part, we are to find ICL bond energy. Let's see. Do we have the values? Boiling point, standard enthalpy change of atomization, and bond energy values. Great, great. So let's try this question. I am going to zoom out so you can see the whole question in a single go. I guess now you can. You're just supposed to solve part 3 of it. Means the
Okay,
one
sir.
that is related to our stuff, because the first one is definition, that is pretty much of memorization. You would also be able to solve part 2. So let's talk about part 3 right now.
Yes, sir.
Take your time, I'm here.
First, I calculated the bond formation for iodine and chlorine. I2 plus Cl2, which is 151 plus 242. It gives us 393. And then I subtracted this value with the enthalpy change, minus 24.
Uh-huh.
And
Don't you
so I got the value minus 7.
don't you think you have ignored the uh, values for the molar values? Have you taken into consideration the balanced chemical equation for this one? I don't think you're doing it correctly. If you were, you shouldn't be talking about the minus 24 value. Okay, take a look at this. Cl2 plus I2 gives us 2ICl. So if you have used this value, this one was what? 100, sorry, 242. If you have this value, 151, you shouldn't be using minus 24 over here. You should be using minus 48. Make
Yes,
sense?
sir.
Because since this is
Yes.
not, but that's not the way we work. Remember, we're talking about bond energies, and when we talk about bond energies, it's better to get one mole of your product. It would be really good if you do it like this: half plus 1 ICL, so that you can take this exact value easily. Since we're talking about bond energies, and bond energies are affected by neighboring molecules, so it's better that we talk about just one mole of this compound. So don't take this value, take half of it. Don't take this value, take half of it, like this, and then you can use minus 24. So, but after either way of correction, what is your answer?
One second. 220.5.
220.5.
5.
Now this sounds somewhat right. Since the number becomes smaller, this one becomes 121, this becomes around 75.5 or something. Now this seems a lot closer to what the answer should be. If you have the marking schemes nearby, do check it. Last time you were saying something around 400, am I right?
Yes, sir.
Okay. This seems closer. I don't know the exact answer. You may go ahead and check. If you say you're right, we can move forward. Are you?
Sir, you have some marking.
Sorry?
Sir, you have the marking scheme.
Yeah, but then I need to scroll. Do you want me to scroll?
No, sir, it's
If you have one closer, go ahead and see. If not, then I can scroll, of course. I was just being a little lazy.
it's okay, sir.
So are you correct?
I'm not sure. I'll check it afterwards.
Okay. Check it afterwards if there is change. If you or maybe I am right or wrong at any place, to let me know, and we can work this one out. But I think you are correct. I think now you're close. 400 seemed to be a big value. Okay. Moving on. Ammonia is again the same one as the example in the book. We're not going to go with this question. You already know how to solve it. Born energies, and this time it's about ethane. Now, I think we did a question about ethane, right? Yeah, when we were doing the practice questions from the book, not from the topical, we had this question, ethane and chlorine. So you already know how to do this one too.
Yes, sir.
Let's not go with this one. Not this one either. You might have noticed that they have used a lot of definitions from this chapter, which should give you an idea that
Yes.
you should be prepared with all the proper standard values of enthalpy changes definitions, be it formation, be it reaction, be it atomization, whatever, combustion, whatever that is. Please be ready to answer a question with 2 or 3 marks for a standard definition from this chapter, since that have been a very important past paper question. Okay, let's take a look at this. Enthalpy change of formation. Okay. Both formation values are given. NH3 is given. H2 is given. We're supposed to find NO. Okay, let's try this one. Since this is also a formation question, but there is a small trick in the question. That's why I'm allowing you to do so. So go ahead, try this one out. Question number 18.
Okay, sir. Sir, we don't have the value for oxygen.
Yeah, that's the trick. Do you remember?
It's a words.
Sorry, your voice broke. I wasn't able to hear you.
I'm saying it's of 4 marks.
Yeah, it's a 4 marks because of the steps, not because of the value of oxygen. Do you remember anything about the value of oxygen?
The value of oxygen.
There was a specific point stating that elements in their natural states are taken as 0. Remember the point? Which means oxygen in its natural state, which right now in this reaction is gaseous, we shouldn't be taking any value. So for oxygen, it would be simply 0. Make sense?
Okay. Yes, sir.
And now you know the trick. I think you can easily solve this one out. Go ahead.
Yes, sir.
Since the equation is already balanced for you, so it shouldn't be a problem. Just put the values and get the answer. Yes, then please include delta H. Try it again and let me know.
Yes, sir.
So where exactly were you making the mistake?
Sir, I think the subtraction.
Okay, understandable. You must have written some